Hi, this is Sai. Today let us discuss about something called big data. Why do we need big data? How big data helps businesses to transform into data-oriented solutions. Let us discuss about that. Before going deep into big data, let's talk about what is data. What is the use of data? Data. Data is nothing but raw facts, or we can say it's nothing but an information which are without a meaning. Data can have meaning, cannot have a meaning, but information must have a meaning. Okay? Anything that we can store, anything that we can work upon is data. For example, Excel file is data. Database, in database we store the data. TXT file is a data. A customer feedback is a data. A rating is a data. So based on the millions of the data, so let's say if I have 100 data points, if I have 100 data, then data is nothing but a plural word. So if I have customer reviews of, let's say I went to a restaurant, I checked the restaurant reviews online, and 100 people has reviewed that restaurant with average rating of 4.5, right? This average rating of 4.5 coming from all the reviews of 5 star, 3 star, 2 star, 4 star, and 1 star, right? So now this is data. So we calculated all the 100 ratings and given an average to it. But we have developed so good in this digital era, digital generation, we are having millions of data points. It's not billions. You know, daily our Facebook or like Instagram, Meta, generating 4 TB of data. What is TB? Petabytes. So let's talk about even that. So one bit is the smallest of the data. If it's 8 bits, we call one byte. So one byte, and if it's 1024 bytes, we call 1 kilobyte. 1024 kilobytes is equal to 1 megabyte. 1024 megabytes is equal to 1 gigabyte. 1024 gigabytes is equal to 1 terabyte. And 1024 terabyte is equal to 1 petabyte. And 4 petabytes of data is generated by the Meta alone. We can store millions of movies in it. We can store like thousands, if not millions of songs in this. Thousands of movies, millions of songs in just 1 petabyte. Now we have this amount of vast data to process. So now let us discuss about that. Now every day, every digital action generates a lot of data. Every click that you make, every payment that you do, every location that you go. Let's let's say I'm using SBI Bank. SBA Bank has a daily millions of data payments, like data of payment transactions that has been happening. Like I alone do almost like 5 to 10 transactions per day. And let's say you are a vendor, you are a restaurant owner, you can expect hundreds, if not some big restaurants can see thousands of payments daily, incoming payments, and then also outgoing payments, right? Now, we are Indians. We have more than 1 billion population, and we are creating more data than the transactions itself. But now, not only transactions. Let's say I'm actually using Instagram. In Instagram, Every like I make, every comment, every share, every report, every view that I see generates a data point. That's why in YouTube, when you watch a video, you can see views, right? That's a data point. Likes count, that's a data point. Dislikes count, it's a data point. Share count, it's a data point. Comments count, it's a data point, and the comment is a data point. Now everything is data here. Now traditional systems fail to handle this much of humongous data. Why? The data is continuous and data is always coming into the system. We need a system which is scalable and reliable, that it can able to handle hundreds, if not thousands of data points, and can able to sustain on it. Now let us understand what is big data and why do we need big data. The traditional databases are very large. The traditional large in the sense, you need, let's say, to store like huge data. If we are going with traditional databases, we will be need one big warehouse. But with big data quantities, the Hadoop or the Hadoop and its ecosystem, we can able to store this data in the other areas, so that in the other databases, like we can see this data, so that we don't need huge and massive infrastructure. This is the one problem the Hadoop is actually, sorry, the big data is actually solving. And we can use the fast, and it's very fast. The Hadoop and its ecosystem is very fast. You know, let's say we have Apache Spark. With Spark, we can integrate with Python. With Python, we can able to do most of the things with the data, and it also can handle the too complex data. Now, let's talk about the types of data and the 5 V's of big data. What are they? Volume. Volume is nothing but the size of the data that we are getting. As I spoke, that we are getting more than 4 petabytes of data from the minutes. And the velocity, the high speed, the speed, nothing but. Let's say an international cricket match is going on, like let's say India versus Pakistan World Cup final. So for that, we have a huge velocity of data. Why? This, let's say, I'm using Hotstar to watch. This is the Hotstar to watch. It is counting the views, right? It is also, it's not only counting the views. Like in between every over, the ads are displayed, right? Let's say today I'm in Punjab. I'm getting ads in Punjabi. If I'm in Andhra, I need to get the ads in Telugu. If I'm in or Tamil Nadu, I'll get the ads in Tamil, right? Now, this huge velocity of data is coming, and the system needs to know where to put the ad, where to show the ad to whom, to which user. Let's say I'm watching, let's say I'm using Hotstar, I'm watching a cricket match in Punjab, and I'm also, like my account is logged in Andhra, my, with my family watching the same match in my account in Andhra. Now, one user, two frames, one frame is Punjabi and another frame is Telugu. So, we need to calculate that, right? And variety. The data is the data is not always structured. It might be structured or unstructured. Sometimes we get the data in clean rows and columns. Sometimes we get the data in the form of Reddit comments. Sometimes, let's say I want to collect opinions of a particular product. Now I read the customer review. Now I don't know the customer review. If I read, as I'm a human, I'll read 10 to 30, 40, 50 comments, then I can say, okay, this is the things about the product. But if the machine wants to learn, then I can't write, right? If I have thousands, if not lakhs of customer reviews, at that time, this helps. So that is unstructured, right? Now, veracity, data quality and reliability. And we need to remember every time that data quality is not same. There might be missing values, null values. It Apache like nothing but the Hadoop handles, the big data handles, the Hadoop and its ecosystem handles. And the value, end of the day, following all these things, what is the value that we are getting and that we are giving to the consumer or the customer or the business. Let's say if I launch a product and my product got volume massive feedbacks and I handled it, I read it, I understood it, and I also discarded the like an invalid feedback or the robotic generated feedback. And then I have understood more about my product and build my product so good, right? This is how business works, and this big data helps the business to do it. Now, here, why actually the traditional databases fail? Traditional, why do we need Hadoop or HDFS? Like, why do we need all these? Simple. The traditional databases are single, they have single machine limitation, which is nothing but, let's say, if that is in this system, it cannot move or it cannot take the other system, cannot integrate directly. We need a integrator, we need a bridge to integrate it. That bridge is provided by the Hadoop and its ecosystem in big data. And we can't do everything with the unstructured data. Let's say, yes, unstructured data is very hard to decode or very hard to work with. Right? With the traditional systems, it's even more hard. And extensive vertical scaling. Let's say I have database 1 here. To go to another database, I need to build the another database physically and need to connect it. It's not possible virtually or like ideally. So, and slow, like when you have large database, it becomes very slow because it will get the CPU bottleneck. You can't scale it. It's not scalable. So, but the Hadoop and its ecosystem is scalable, and it's not designed for distributed processing. Let me tell you the distributed processing. Let's say I am processing task 1, task 2, task 3, task 4, task 5 are pending and waiting for the CPU. But here, what are we doing is we are communicating with many devices and we are processing parallelly task 1, 2, 3, 4, 5, and 6 simultaneously. And they work. So, yeah, the core idea of big data is very simple. We distribute the data, we process it in parallel, and we scale it horizontally, not vertically, horizontally. And let's say I have taken 10 systems. One system has failed and it will get a backup. It's nothing but the fault tolerant system built in the Hadoop and its ecosystem itself. And it also handles the failure. Important. Now let us understand about the Hadoop, like Hadoop Big Data and Hadoop through a small example, small restaurant example. Let's say, let's say Sai, my name is Sai, as you know. I started my own restaurant. It's called Restaurant Sai or Sai's Restaurant. Now that Sai's restaurant has it's a small restaurant. Like we start small, right? Yeah, it's a small restaurant. We started with one chef, one waiter, and we are getting 2 orders per hour. And so Sai's restaurant has one chef, one waiter getting 2 orders, which is nothing but chef is make 2 orders, okay, 2 orders per, which is nothing but chef is making two or taking one dish 30 minutes, and waiter is also one dish for 30 minutes, right? Now, Sai heard about digital marketing and understood about it, and he marketed his restaurant. Then it became popular because of its taste. Now, it started from 2 orders per hour to 10 orders per hour. Now, what happened? We got into the situation. We have 10 orders per hour. Now, we have only 2 chefs. One chef can able to cook a dish in 30 minutes. Now, what happens? The chef can able to cook only 2 dishes per hour, right? Yeah, it's good. But the problem is we have 8 more waiting. Now this is the problem. This is the problem. Now let's see how Hadoop solves it. Now what actually happening is the system became slow. The resources became overloaded and the performance decreased eventually. Now chefs can't cook fast, right? Like we can't do, and waiters can't able to do all things at the same time, and we are finding the unhappy customers, and it is going down to the business. Now what Sai did is he hired 5 more chefs. Total now we have 6 chefs and only one waiter. So to increase efficiency, Sai hired 5 more chefs. So now we can cook 6 into 2, 12 dish per hour. Oh, that's great. But we have only one waiter, one kitchen, right? Or one kitchen or one freezer where we take the items. Now this is called the resource bottleneck because we have the one which can do the task. But let's say chef one is using this kitchen. All the chefs need to wait, right? Now this is the resource bottleneck that we are facing now. Now you can say we have one kitchen, one shared ingredient, limited tools. Let's, because we can add the processor, but we can't add the storage, we can't scale the storage, and there are IO bottlenecks as you can see. Let's say I want to use this remote. Let's say I'm watching TV. There is a friend of mine want to watch the TV. After I complete the movie, he will watch. But there are 5 more waiting to watch the movie, that they like, right? Now we have the bottleneck, input bottleneck. One TV, multiple users wanted to use it. Now to solve that, we redesigned the entire concept. We have made the 6 chefs, 2 chefs for meat, 2 chefs for sauce, 2 chefs plating. Plating meat is nothing but cooking, sauce is nothing but the plating, making the gravies and all this, and 2 chefs to make the dishes properly, like to arrange it to serve it. Now we also made the entire system. We have created 4 stores, 2 for mixture, 2 for sauces, and we got the new tools like meat grinder, sauce mixers, and everything. And with this, we can do more processing more efficiently. We are dividing the orders by type and giving it to the specialized team and completing the dishes and making the customer happy. So, this is the story of big data in a nutshell. And this is Lansai. Thank you so much.